So it is National Make a Vacuum Day. And so we were wondering about how it is we were going to do this, and we decided that using an ancient method of coffee brewing would be our best way. So this is called siphon coffee, or a siphon brewing pot. It was actually started in Belgium in the 1830s. And it's a really unique way to make coffee for a number of different reasons. So we fill this lower boiling chamber with water. And that water, I've cheated a little bit. It's already hot just to speed up the process. Otherwise it takes a really long time. And then I've actually got this second chamber that has a long tube that comes down. And then there's a filter. It's a cloth filter that goes in between. So I've got to start by fixing that into place. And it's actually going to be spring-loaded and locked in so that I can hold that down. And that's going to go onto this top pot. And when I push this in, it's going to create a seal so that this bottom chamber is now sealed off. So now what I need to do is heat this water the rest of the way to boiling. And to do that, I just have an old-fashioned alcohol flame. And again, like, you want to be careful because we got open flames. Don't worry, Sean has a fire extinguisher at the ready. And I'm going to put that under here, and now literally I just kind of walk away for a while. But you can start to see the water right next to the flame is already beginning to hit that boiling point, and you're starting to see some of those bubbles come up.
And that's because, for time's sake, we started with water that was still pretty warm, because we didn't think you wanted to sit and watch us boiling water. But we didn't add coffee yet because we want you to see what happens next.
We start to look now, you can see we're starting to have some of that water is changing from its liquid state into a gaseous state. And when that happens, it's going to move up through that tube, and it starts to condense or starts to push its way up through this filter, and now we have a wet filter. So you can see this thin layer of water right here, right now. We're still not at like the true boiling point of the water, but we have some of the water that's starting to evaporate. When we hit the boiling point of water, we're going to have a big spectacular event happen all at once. We start to look, you can start to see the water vapor shooting out of the top, like we're getting a lot more water vapor moving. And because the glass up here is cooler than the glass down here, you're starting to see some of that water vapor condense around this outside. The same reason that your can of soda sweats at home. Is because of that change in temperature. If you've got lots of water vapor around a cold surface, that water vapor is going to condense on it because the temperature of the air determines how much moisture it can actually hold. Again, the more water that moves up here, the less water volume I have down here, the faster this is going to boil. As it boils, it's going to expand as it changes states from a liquid to a gas, and as it changes those states, it's going to push down and force that water up this tube into this top chamber. And you'll notice that the chamber up on top, the water up here is indeed boiling, and shabam, everything shot up. We now have almost exactly the right change or difference in pressure between this bottom and top. As the water comes back down, again, that small volume almost instantaneously turns into. I'm going to put in a couple of good heaps. There's one, there's two, there's three, and I'm going to put in another half of one because I've got about 700 milliliters of water in that bottom chamber. And now I could actually, if I was really patient, I could sit here and wait and let it do its own thing, but I've already waited long enough for my glorious cup of coffee. So I'm going to use my little paddle here to stir my coffee grounds in, and I'm going to let it steep for about 5 minutes.
So why do you keep the heat on the bottom still?
If I move that heat from the bottom, again, that bottom chamber is going to cool rapidly, and when we have that bottom chamber cool rapidly, it's going to actually cause it to contract. So you're going to have this tiny change in pressure once again. This ambient pressure is going to be at 1. This pressure down below is going to be at 0.9599. a lot. It's going to be almost 1, just a kiss under 1, and it's going to cause that to create a vacuum. It's going to pull everything back through along with the force of gravity. So coming down is a lot faster than going up. So the second that we remove that, you want to make sure you put your flame out. Again, we're now not heating that bottom chamber anymore. The second that happens, that air cools rapidly, and as it cools, it contracts. When it contracts, it's going to start a vacuum, and it's going to pull that down, assisted by gravity. We're going to fill that bottom chamber, and this is why having that filter in place was important, and it was important to have it spring-loaded. So 1830s is when we started using this as a brewing method. It actually became very, very popular, but of course today nobody wants to wait 50 minutes to make a pot of coffee. Sean, your cup of coffee.
Your cup of coffee, Sean.
Wicked hot. It's a good cup of coffee.
It's good. That's very warm, though. So we could actually model this with our water kit.
Absolutely. And
So-
while we enjoy our coffee,
We're going to do that for you.
we should switch.
Yeah. So we have our coffee, and now we're going to model with the water kit. And just for your edification and notes, we've used 4 cups of water for this, and that's not nearly enough. So if you can think back to what you just watched with the making of the coffee, in the reservoir you've got liquid, but then what happens?
Well, we start heating it from below, and as it's heated, you're going to have some of these water molecules actually gain enough kinetic energy that they're going to actually start jumping from liquid state to gaseous state. And so you're going to have some of these guys breaking off, and this whole time this is just this big swirling dervish of all these water molecules moving around. And as they're doing that, sometimes they're bonding to other water molecules, and then sometimes they're breaking off and they bond to another one, and that's just constantly happening inside of this. But as we add more heat, some of these actually get enough kinetic energy that they'll break away and turn into a water vapor. And when that happens, a lot of cool stuff starts to happen. They are going to actually start to expand, and because we have these plugs underneath to actually block this chamber down below, the only path it has is to come up through that tube that's running through the center. So as that starts to happen, we get pressure starting to build up inside of this, and it's going to travel through the area where, hey, the least amount of resistance. I've got an area of high pressure down here. Once again, we've got a lower area of pressure up here, and you're going to start having those water molecules move up. As that's happening, what happens to the volume of the water in the chamber down below? Well, that water chamber gets lower and lower, and as a result, it's going to be able to heat it up faster. There's less physical stuff there, so it's going to actually reach that boiling point faster, and that's where we got that big movement of all the water all at once. There's some other exciting stuff happening along with that as well. Because of the way water is polar, as it's moving up, it's not only sticking to other water molecules, but it's also going to be sticking to the sides of the glass. So we have to actually start overcoming not only cohesion, but also, we're using the cohesion to actually help pull it up. We have to get over the forces of adhesion with the side of the tube, and the pressure that's pushing down, and the gravity that's pulling everything down. But once we get to a specific point, and that specific point is 1.015 atmospheres, so 1.5% change in atmospheric pressure from this bottom chamber to the top is enough to overcome all of those forces. And once that happens, I pull on one, and they all start to move together. We actually have a little bit left here. So
Yes,
we
go
get to
for
this
it.
last part. We've got all of our water up here. We've got a filter inside of this. We start adding our coffee grounds. We actually have some water molecules that, as they're being pulled up, they actually don't have enough energy anymore. And what will happen is those will drop down here to the bottom. You have a little pool of water at the bottom. Because there's so little down here, it evaporates really quickly, and it generates that pressure to push everything back up. But again, gravity's pulling down. Some of those will drop off. Again, having that flame down here is what allows us to keep boiling those little bits of water to keep that pressure going so that everything stays up. This is where we start steeping our coffee up there in that top chamber. And then when we want it to come back through, all we have to do is put that fire out. The second I put that fire out, the air inside of this starts to contract just a little bit. It starts to create a vacuum, and then gravity is going to pull everything back down. It's all going to pass through that filter, which now my filter is like totally gone in my little sketch, but everything drops back down to this bottom chamber, and now we've got our beautiful cup of coffee.
So that is our contribution to make a vacuum